Hi, my name is Leland Randalls, and this is my final project presentation for Data 608, Spring 2019 semester. I'll briefly go through my data sources, my exploratory data analysis, and code, and then we'll go straight into demoing the visualizations. Everything that I'm going to discuss is available at my GitHub repo for the final project in the course, the URL of which is here. Pretty extensive documentation out here. And the ultimate product, which is a Shiny dashboard, can be viewed at this URL. I'm marrying two data sets. One is the CDC alcohol attributable deaths due to excessive alcohol use. This takes the average by the various categories, which are state, age range, gender, and cause, okay, for a 4-year period and reports them in 2010. So it's a static data set that's showing an average. It is not showing amounts for each year over this period. It's just showing the average as of 2010. I'm marrying that to census data. Of course, I picked the 2010 census, also freely available. And it's by age range, state, and male or female. Glancing briefly at the exploratory data analysis, it's in the spreadsheet. You can view it yourself. The challenges with this data set were twofold. One was aligning the age ranges, and the other is the fact that the CDC website will report things under multiple categories. So you have to decide whether to either include all the categories and have them be in your dropdown, and if you do that, you need to know to filter out some of them when doing dynamic aggregations, or you can choose to exclude them from the get-go. Okay, for example, in addition to numbers for every state, they also have a line for US. Glancing briefly at the code, essentially the first half of the code does everything that's needed to marry the data sets by state, age, and sex. So all of this is done to read in the data sets and eventually merge them and format as desired. Also compute per capita and some other stats that are essential to the visualizations. Then we build a Shiny dashboard that essentially has 3 inputs, cause, sex, and age group, and 2 buttons that are used to toggle sorts. Okay. Then within this we have 3 visualizations, a chloropleth map, a sorted bar chart, and an over 21 versus under 21 population pyramid type of thing. Only instead of using population on the y-axis, it uses state. Down here is all of the code that goes with any Shiny dashboard, where you have reactive data sets that respond to what's inputted. And then you have the various plots. The first 2, the map and the sorted bar chart, were done via Plotly, and the last one was done using ggplot. So let's look at the visualizations. I'm starting with all causes, all sexes, and all ages selected. We have these various age ranges, and the data set also split things between under 21 and over 21. Sexes is all female, male. And then the causes, we have 56 distinct causes. Here are the visualizations themselves. If you look at the map and hover over any state, it will give you the average number of deaths, the population, and then the per capita figure. So for everything selected, all sexes, all age groups, all causes, New Mexico has the highest rate, per capita rate for deaths from alcohol. Below, we have the per capita rates sorted in a bar chart. The line that's across it is a national average, so you can see who's above the national average and who's below the national average, as well as highest to lowest, which you can sort back and forth. Lastly, here's the thing that I told you looks sort of like a population pyramid. It shows under 21 and over 21 by state, sorted from the most prevalent to the least prevalent, or if you toggle the other way around. So let's look at some of the causes. Let's say that we're looking at motor vehicle crashes. Of course, it's all dynamic. Once you make a selection, it changes. We can see that Wyoming, Mississippi, and Montana are particularly high. We can see that again here, Mississippi, Wyoming, Montana. We can see the national average. We can see who's above and below the national average. We can sort it if we like. And then we see the over 21 and under 21. You can see that, if anything, under 21 seems more heavily weighted than we would expect. I wish I would have done this as a percentage of the under 21 and a percentage of the over 21. But I don't have time to change it at this point in the game. We can kind of look and see whether we get any big variations between male and female. If we look at male, their scale goes from 0 to 140. If we look at female, the scale goes from 0 to 40. So that doesn't necessarily surprise me. I would expect more male car crash deaths than female. We're not seeing a huge, when it comes to under 21 versus over 21 distribution, we're not seeing a big difference between male and female. Female looks like this. Male looks like this. If anything, it seems to suggest that it's more common for under 21 females than males. We could look at suicide. For this, I'm going to look at all sex. But then I'm going to look at the various age ranges. When we look at 0 to 19, our scale goes 0 to 16. If we look at 50 to 64, our scale goes 0 to 70. So suicide is much more common amongst 50 to 64-year-olds than it is 0 to 19-year-olds. So I'll let you play around with the application yourself and see all the various things that can be done. And I appreciate you giving me my time. Thanks. Bye-bye.